Coming up on Omnivore, using cold plasma for clean label wheat processing, and the downsides of delaying FSMA. It's all ahead on episode 62 of Omnivore from the editors of Food Technology Magazine and the Institute of Food Technologists.
This episode of Omnivore is brought to you by IFT FIRST, where the future of food takes shape. Join thousands of changemakers and innovators at Chicago's McCormick Place, July 13th through 16th, for the food industry's can't-miss event of the year. Connect with global leaders, experience breakthrough technologies, and be part of the conversations defining tomorrow's food landscape. Secure your spot at iftevent.org.
Welcome to Omnivore from IFT and Food Technology, where we explore the intersection of business, science, and technology in the global food system. I'm Bill McDowell. Shikadri Mahanta is a PhD student in agriculture and biological engineering who cares passionately about reducing food waste. That passion led her to a research opportunity at Texas A&M University focused on reducing post-harvest grain loss. In a conversation with Food Technology's Mary Ellen Kuhn, she discusses the potential for a cutting-edge, non-thermal, non-chemical technology called atmospheric cold plasma to improve wheat flour processing in a clean label way.
Shikadri, you're a PhD student at Texas A&M University working on a research project with Dr. Janie Moore in the Department of Biological and Agricultural Engineering, and also Dr. Jane Bhatt at the Wheat Marketing Center in Oregon State University. I understand that you're passionate about the topic of reducing post-harvest food waste. What's driving that?
I have been interested in all my life. Also because from my own personal experiences that I'm from India, I did my undergrad in India. Although like a huge population of India is well fed, but there are sometimes during certain natural calamities, like my region is often affected by flood, and during that time we do see food insecurity. So those things have always motivated me to think, what are the ways that, because it's not that the food is not available, like food is not there, it's there, but it's just not available at that time. So there is some lack in storage and distribution. So there are some challenges. So I was very interested to understand the problem. And I'm grateful that I have this opportunity to continue my research.
Could you talk to us a little bit about the scope of post-harvest food waste? Just how big of a problem is it?
As we know that the world today produces enough food, like enough food to feed more than the whole population. Even it can feed 1.5 times the population. But still we see that there is a huge part of the human population which is malnourished or they are in hunger. So that was one of my goals, like how I can improve global food security and reduce global hunger through my scientific research, because I feel I do my best while doing research. And since cereals and grains are a staple crop all over the world since ages of human population, so this is the best way I feel I can contribute more globally. So some recent reports even suggest that losses of cereals and grains can go up to 40% in the post-harvest. That's one of the reasons I chose post-harvest, because that involves a lot of engineering and at the same time improving food safety.
Wow, 40%. That's incredible.
That is a lot.
Well, so on your research project, you worked with Dr. Moore at Texas A&M and also a food scientist from Oregon State University to come up with a flour treatment process. And it involved a process that's called atmospheric cold plasma. So I think we need to really start with an explanation of what exactly atmospheric cold plasma is in simple terms.
Okay. Very well. Atmospheric cold plasma, it's a non-thermal, non-chemical treatment. So to explain the terms, atmospheric means it is in the atmospheric pressure. There is no high pressure, or we do not need a environment of high or low pressure. It can be done in atmospheric pressure. and cold is like no high heat or no low temperature is needed. And plasma is the fourth state of matter. So plasma is the state, for example, when you see thunder, which is the state of very high energy, that is plasma. So over the years, scientists have harnessed this high state of energy to treat in different fields. For example, it is used in medicine, in the medical industry. It is used in many many chemistry, let's say chemistry projects and chemical work, I would say. And we are exploring this atmospheric cold plasma in different food products. So what we do is like we take air in an enclosed space and pass high voltage electricity to it. Due to the high voltage electricity, the air inside the package, it gets ionized. There are like over 75 chemical reactions that is occurring and more than 500 reactive products that can be produced in a plasma. And these are like very active and they start reacting with the food that we are treating. And in exchange, when we are doing it in a controlled amount, in exchange, it can give us some desirable functional properties to the food, which we can do otherwise. For example, in my case, I'm trying to reduce chlorination in wheat flour. So instead of chlorination, what it does, it oxidizes the flour. So instead of using chlorine, we are using air, which is a natural source. So that's what is atmospheric cold plasma. And I have been very lucky to be working under supervision of Dr. Morse, is an expert in plasma, and Dr. Janie Boggs, he is from the Wheat Marketing Center and also associated with Oregon State University. And together, so we are trying to enhance flour functionality and reduce chemicals in flour because, flour is used in everyday food. Everything that we eat has some amount of flour, and to make it more natural so that our consumers, so that people can have access to more safer foods with less chemicals.
Well, that was a great explanation. Let's talk a little bit more about the chlorination. Why might we want a substitute for chlorination?
Very well. Yeah. So chlorination, it has been popular since the last couple of decades as a method to reduce microbes, to enhance the microbiological quality of food. Like you can see, water is also chlorinated to enhance its quality. Similarly, wheat flour, when we like get it from the nature, the wheat flour from the fields, it is not in uniform state. So from different batches, from different locations, the flour has different functional properties. To do that, in the industry, they use a process called chlorination, which actually modifies the flour structure so that the products that we can prepare from the treated flour is uniform across different batches, and also enhance its water holding ability, its baking ability, etc. But as we all know that we are now discovering and exploring that there are more and more chemicals in our food, and we should try to reduce as much as we can. Since chlorine is not really good for our health. The chlorine residues which remain in the wheat flour that can get accumulated over time, and if we are consuming it like bread, cakes, these are like common food that we consume frequently, and not just for maybe cake we consume a little bit lesser than bread, but in many parts of the world, bread is just a staple food. So when we use chemicals like chlorine in foods, which we consume very frequently, it's not good for our health. So we need to explore into more natural ways of treating the products so that our health is not impacted over time. Chlorine is associated with some carcinogenic effects, some mutagenic effects, it has some long-term effects, which is still, as human beings, we are understanding. So, and consumer demand for cleaner products have been increasing in the last couple of years. So, yeah, so atmospheric cold plasma, I see that it has a lot of potential. In some cases, it even produces products better than chlorinated wheat flour. So there lies a potential of applying this non-chemical treatment to wheat flour while we get the same industrial quality, but with lesser chemicals.
Well, that was well stated. I want to take you back to that. You mentioned that it had potential carcinogenic effects. What were some of the other things that you mentioned?
Mutagenic.
Okay.
So it can change the genetic makeup over time. So the chlorination was one part of my objective. I actually, when I was doing literature study, that actually caught our interest that chlorination, actually it has been banned in the European countries, but it is still accepted in the US and many other countries. So there is a high chances that in future, even in the other countries, chlorine is banned. And at that time, we might need some real solutions, which is actually helpful.
So what about adoption in the food industry? Is it feasible, or would more research be needed before that step could be taken, do you think?
I would very much like to say that we can just adopt it immediately, because I can see very good results on my personal end. But I think just like any other technology, it has its own challenges of scalability and adoption in the industry, and also government laws, because since I'm not aware if there are any current laws which allows plasma treatment in food. So that can be one of the main challenges of adopting in the industry. Another thing is the scalability, because whatever we have done in smaller lab scale to do it in like huge amount. And the Wheat Marketing Center is also a pilot scale production. It's not in like commercial scale. So definitely when we are implementing this technology in a large commercial scale, we need more research how to actually, it would be very helpful if we can develop some models to determine the amount of plasma treatment required for a certain amount of compound, because, the amount of plasma generated changes according to the size of the electrodes, amount of the product, and also the type of air and the amount of air we are using to ionize. So definitely having a model to address the whole research would be the next step, and then implementing in the industry for industries to actually get good results and to see long-term effects. That would be another step. But I do see a lot of potential in future if more industries are interested. I would very much like to work together and continue the research. As scientific researchers, we do have the responsibility of making the world better place. And since our research is in food, so make the world better place for food.
Shikadri Mahanta is a doctoral student in agricultural and biological engineering at Texas A&M University. Learn more about her efforts to apply atmospheric cold plasma technology to wheat processing in the June issue of Food Technology. We'll be back with more Omnivore in a moment, but first, this word from our sponsor.
This episode is brought to you by IFT FIRST, the food industry's can't-miss event coming to Chicago's McCormick Place, July 13 through 16. Want to first look at the future of food R&D? This year, IFT FIRST is exclusively unveiling a groundbreaking AI solution that taps into 85 years of scientific data. It's not just another tech tool, it's a virtual co-developer designed with food scientists for food scientists. Experience breakthrough technologies, connect with global leaders, and be part of the conversations that matter. Don't miss this game-changing moment in food science. Register now at iftevent.org. That's iftevent.org.
Welcome back to Omnivore. I'm Bill McDowell. The FDA's Food Traceability Rule, part of the Food Safety Modernization Act, or FSMA, was designed to help regulators more quickly identify the source of foodborne illness outbreaks. The new rule was set to take effect in January 2026, but in March, the agency announced plans to delay the compliance date by 30 months, citing the need for better coordination across the supply chain. The move has sparked a debate. Is the extension a necessary step towards effective implementation, or a sign that the industry simply isn't moving fast enough? Food Technology's Kelly Hensel spoke with food safety experts Jennifer McEntire and Tejas Bhatt, who co-led the original FSMA traceability pilots for FDA. They discussed the intent behind the rule, the challenges of industry adoption, and why waiting for the perfect solution could put consumers at greater risk.
You guys both have a long history with traceability, and having co-led the FDA's FSMA traceability pilots while you were at the Institute of Food Technologists. And I was thinking about, as you guys look back at that work and seeing where we are today with this 30-month extension announcement, how do you feel like the conversation around traceability has evolved over the past decade? And kind of, are you surprised that we're still facing some of these same challenges?
I'm ready to be done talking about traceability. When I began at IFT, it was 2008. And we look at this delay will take us to 2028. That's 20 years to be talking about the same topic is kind of a long time. Now, a lot has changed. Supply chains have changed. I think technology and our ability to work with data, the use of digital data to connect data, that's probably been a big change in the right direction. But the changes in outbreak investigations, the challenges that we face, those haven't fundamentally changed, quite frankly.
Funny to hear you say that, Jennifer, because I was hoping you'd be the optimist between the two of us and I'd be the cynic. But I agree with everything you've said. It's been frustrating that the conversation around traceability has not changed a whole lot in the last 20 years. And I think there are a couple of things that we have changed when it comes to traceability. The conversation around traceability. One is, I remember back in 2012 when we did those pilots, Jennifer, there was still a debate going on whether traceability was a reactive tool or a preventive tool, right, to food safety. And I think more and more now people have recognized that it has a role in prevention. It's not just a recall readiness tool. It's not just about reacting to outbreaks after they've happened, but it does help us get to root cause faster and, essentially solve for preventing future outbreaks from happening. Completely agree that the role of technology has changed. We have a lot more advanced technologies that can help us do traceability better, cheaper, faster, more accurately. So that's great news. And the last thing I wanted to say here was, unfortunately, industry readiness has not changed. So even though we know a lot more about the role of traceability, the practices and the processes around traceability in the industry as a whole have not changed a whole lot. Some companies have made some improvements, but as a whole, I've not seen much of a change.
This is a very somber start to this interview, but I appreciate both of you being so candid about the situation. And Tejas, you mentioned, some of that shift to seeing this not just as a reactive tool, but as a preventative measure. This is for both of you. How can companies reframe their approach to see it more as like an asset rather than just another, regulatory checkbox that they have to get through?
Yeah, I can start if you want, Jennifer. So, what we have increasing evidence of is that traceability and the data that you collect through traceability actually has a much larger impact on business than it does on compliance and regulatory compliance specifically. So for example, the data that you collect and the fact that you can now know in near real time where the food is coming from, where it's going, and how it's being handled, you can use that data to reduce food waste, to mitigate food fraud, to improve food defense, for sustainability metrics and improving your social responsibility metrics. We use it at Walmart for responsible sourcing, making sure that there's no forced labor in our supply chains. And from a business point of view, one of the things that we see is you can use the same data for measuring quality metrics, shelf life, freshness, and drive improved consumer or customer satisfaction from this data. And so the more you reframe this away from regulatory compliance and towards business benefits, what happens is you end up having the merchandising organization or the quality organization of the company leading this charge. And a byproduct of that is, by the way, regulatory compliance.
Yeah, I totally agree, Tejas. And I was going to say traceability is a byproduct of good record keeping. When you have good record keeping, it provides many values. And I think today more than ever, with social media, with just the social discussions that we're having within society about transparency, there's an interest on the part of consumers in knowing where their food came from, what's in their food. And so I see a market opportunity for companies who are able to provide consumers with more information, and the record keeping that enables traceability, that helps companies tell their story. Food safety itself, and especially regulatory compliance, if you as a company believe, I'm not going to be involved in an outbreak, I'm not going to have a recall, traceability is not a strong selling point. It becomes looked at as an unnecessary cost and unnecessary burden, because those are, fortunately, pretty rare events. But to look at those other benefits, those things that provide a return on investment for the business, which at this point enough work has been done to start to quantify those, that should be the motivating factor for companies. It's the bigger business opportunity.
The FDA justified this 30-month extension by pointing to that supply chain coordination challenges. Even obviously among companies that were ready, they're, 2 steps up, they're not ready. 2 steps back, they're not ready. Is this a necessary pause? Is it, do you think that it might encourage further delays once 30 months has passed?
We don't think this is a necessary delay. And in fact, there's unfortunately, a pretty high likelihood that 30 months from now, we're going to hear the industry complain about the need for more extensions or more delays. We hope we're proven wrong. I would be delighted if I was proven wrong. But I think the reality is, in some instances, we're seeing companies trying to wait for the perfect solution instead of trying to implement something that is good enough to move this industry forward. I think that if I was trying to be optimistic, I hope companies will use this extra time to try and do traceability the right way, instead of trying to put band-aid solutions in place that may not be scalable, that may not be sustainable. It's one thing to have a traceability program or a traceability process in place. It's completely another thing to make sure that it's accurate and it's timely.
I think companies now are in a bit of maybe a precarious position because, God forbid, there is an outbreak in the next, 3 years. If companies and supply chains aren't able to trace products, I think it gives those skeptics, those pundits, a lot of fodder to criticize the industry and to say, hey, you pushed this back. You don't care about public health. And I don't think that's true. But I do fear that could become the narrative if something major, something catastrophic were to happen.
You mentioned, Tejas, the companies trying to wait for that perfect solution. And you also said that you hope that they take the time to do this the right way, right? To take the 30 months to do it the right way. So how do you make that balance? How do you make that decision, or what kind of recommendations would you advise for companies? I know obviously you're coming from these large scale traceability systems at Walmart. There's lots of great new technology. How do you make those decisions to do it, the way that's available now? It's right today, but there may be better solutions down the road.
Yeah, it's going to really depend on each individual company and what their starting point is. The first problem you have to solve is not a technological one. You should not start with what system should I be using for my traceability record keeping. It is really taking a hard look at your processes and trying to figure out which of those processes have an impact on traceability. How are you capturing that data today? And trying to figure out how do you digitize that data in any shape or form. For small companies, that may just be a simple spreadsheet, and that's fine. That works depending on the volume of that company. Technology will always evolve, will always innovate, will always change, right? You will always have this next big thing that's on the horizon. The biggest advice I have is to make sure you're following global standards. If you are following global standards, it is relatively easy to switch from one technology to the other as new technology evolves. You will have a diversity of software solution providers that need to interoperate with each other using global standards to share data across the supply chain, to maintain that integrity of that data. And so the role of the industry, as I see it, is to push their technology solution providers to work well with each other, rather than trying to pick a winner and a loser when it comes to a tech provider, because that's never going to work at the scale of the food industry.
What's the one step that, companies who are still hesitant to act can take today? And it made me think, is it talking to your suppliers? Is it talking to the other people in your supply chain? Is it looking at, like how you said, Tejas, what are you collecting now and how you're collecting it? Where do people start?
I think the biggest hurdle the companies have to overcome is inertia. The motivation to not do anything is so strong that they have to figure out a reason why acting makes sense for them as an individual company. And we talked earlier in this conversation around all the different reasons beyond regulatory compliance why it might make sense to do more on traceability. So once they find that North Star for them, then the next step would be to talk to their supply chain partners upstream and downstream to figure out what are they doing to improve their traceability practices and essentially take it from there.
When I address larger groups on this topic, I usually start with a discussion of why does this rule exist and what is the problem the regulators are trying to solve? And I think when people realize how they fit in to this outbreak investigation equation where regulators don't know the lot numbers, they may not even be totally certain of what food they should be investigating. And they're trying to stitch this information to see if between many different points of sale, points of service, ill people, if they have something in common. Further back in the supply chain, is there some physical location and point in time that's in common where food was produced, where contamination may have happened? Given all the uncertainties, this is where I think companies need to see how their records, how this information fits into this much bigger, really messy type of puzzle. If they don't get that and they think that what they have is adequate because they don't see how it fits in, I think that reinforces that inertia, that feeling that I'm good enough.
I'm hoping that, as you guys have stated in this wonderful interview, that this 30 months is used proactively. People are, not sitting back and waiting till month 29 and wondering what's going to happen or requesting more time. Only time will tell, I guess. Any final thoughts? Any final word?
Yeah, I think one thing I'm hopeful for is, unfortunately, to date, generally speaking, we've been trying to apply 20th century thinking to solving 21st century problems. And to think about traceability as a process whereby you have to scan every single case, scan every single pallet, scan every single product as it's moving through the supply chain is old school thinking.
Yeah.
I obviously have a bias towards technology. So I'll acknowledge that bias up front, but I'm really hopeful and cautiously optimistic that technology is going to be the unlock to solving this at scale, at the scale of the food industry, from things like computer vision technologies to IoT sensors to even in some instances blockchain. Like those are the kinds of technologies that I think will create that unlock for the industry to do this the right way and to do it at scale in a sustainable manner.
Jennifer McEntire is the founder of Food Safety Strategy and the former Chief Food Safety and Regulatory Officer at the International Fresh Produce Association. Tejas Bhatt is founder and CEO of Advantageous and an incoming member of IFT's Board of Directors. Read their thoughts on why the industry should act on traceability now, despite the FDA's delay, in the June issue of Food Technology.
Our thanks to IFT FIRST, food improved by research, science, and technology, for feeding this episode to your ears. Don't miss your chance to be part of the year's biggest food science and innovation gathering in Chicago this July. Connect with the minds cooking up tomorrow's innovations, get a taste of breakthrough technologies, and join conversations that matter for our food future. Register today at iftevent.org.
And that wraps up another episode of Omnivore. Thanks again to all our guests and my colleagues at Food Technology. If you enjoyed today's discussion and want to be part of the conversation shaping the future of food, join us in Chicago this July at IFT FIRST, where the leading minds in the global food system connect, innovate, and drive meaningful change. Learn more about this year's agenda at iftevent.org. Omnivore is produced and distributed by the Institute of Food Technologists. For more discussions about discovery across the food sciences, check out IFT's other podcast, Side Dish, on the News and Publications page of IFT.org. For all my colleagues at IFT, thanks for listening and join us again for our next episode. This is Omnivore.